but I'll be on it always, always.
Hey, welcome back to the Pink Chemist. So today we are going to write ionic chemical formulas. Now we got quite a bit of examples to do, so I'm going to go ahead and hop right into it. Now on the screen, what I do have is steps on how to write your ionic formulas, and then I also have the oxidation numbers so that you can follow from the periodic table where I'm getting the oxidation numbers, pairing them with my element symbol so that we can do a process of what we call swap and drop. Now, I'm going to hop right into it because the process is fairly easy. You just got to make sure that you're following the steps. Okay, so first things first. When you're writing a chemical formula, what you're doing is you're going to write the symbol for the metal with its oxidation number. So the example that I'm going to go ahead and use is lithium and chlorine. Okay. So when you have an ionic bond, that means that you have a metal and a non-metal paired with each other. Okay. That's the only way that it can be an ionic bond. Now, when you are writing the formula, you're going to take the symbol. So when we look at the periodic table, we know that the symbol for lithium is Li. Okay. And then we're going to pair it with the oxidation number. When I look at the oxidation number for lithium is +1. So I am going to write a +1 at the top of the element symbol. Then for chlorine, the symbol for chlorine is Cl, and the oxidation number for Cl is -1. Now, when we're doing the process called swap and drop, what we're doing is we are swapping the oxidation number of the element to the other element. So that's what it means by swapping. So I took arrows and I pointed the arrows to exactly where that oxidation number is going. So in this instance, when we rewrite our formula, I'm going to have Li and Cl. Now you will notice that because both of my oxidation numbers for lithium and chloride was 1, I did not write them as subscripts. When you have 1, you do not have to write them as subscripts. I also want to note that when you're swapping and dropping, you do not bring the charge down. Okay? You do not bring the charge down. Now I'm going to go ahead and do another example. I'm going to do another example. Let's do another one. So let's do potassium and oxygen. So I got a metal and a non-metal. And then I'm going to start off by writing the symbol for my metal, which for potassium, my symbol is K. Please make sure that you're looking at your periodic table and identifying which symbol matches the element, because some people write P for potassium and P is not the symbol for potassium. So make sure that you're paying attention to that, okay? The oxidation number for potassium is +1. It is in group 1. And then for oxygen, the symbol is O. And then the oxidation number for oxygen is -2. Now, when I do the swap and drop, I am going to take my arrows. I am making arrows showing you exactly where that number should be next to that element symbol. Please make sure that you're following the arrows. And when you drop your oxidation numbers down as subscripts, you are not bringing the charge. You're just bringing the numbers. So what your formula will look like in the end is K2O. Remember, when we have 1 as an oxidation number, we do not write the 1 as a subscript. And this is going to be our ionic chemical formula for potassium oxygen, K2O. All right. So we're getting through this, but that should be pretty easy. That should be pretty easy. I want to give you one to try on your own. Okay. I want to give you one to try on your own. Let's do calcium fluoride. Oops. Let me spell that correctly. Calcium fluoride. And with the calcium fluoride, I'm going to leave this here. You're going to do it on your own because I know it already popped up on the screen. And then on the very last page, I am going to write the answer for the calcium fluoride, okay? So we'll come back to that one. All right, so next, how do we handle when we have a polyatomic ion? Now, this is different from when we just had the elements from the periodic table. Now, I do have on the screen examples of polyatomic ions. Now, when you have a polyatomic ions, you can go ahead and get the symbol as well as the oxidation numbers for your polyatomic ions right off of the polyatomic ion sheet. Now, how you can identify that you have a polyatomic ion is because most polyatomic ions end in ATE or ITE. And if you look, I'm going to go through, you can see here, it ends in ATE, ITE. You see that? So if the element ends in ATE or ITE, it is likely a polyatomic ion, okay? We write parentheses around our polyatomic ions because polyatomic ions are essentially nonmetals, but they are joined together with two nonmetals. And if you're not careful, you may think that you're dealing with a covalent bond, which covalent bonds is the bonding of two nonmetals. But when you have a polyatomic ion, your polyatomic ion actually have a charge, okay? So you want to be careful with that. And these nonmetals are what are associated with being bonded with your metals to make an ionic bond. So please make sure you pay attention to that. Okay, so when it comes to polyatomic ions, you're essentially going to do the same thing that you did when you just had regular metals. So I'm going to give you an example. Let's do calcium. Why can't I spell? Give me 1 second. So we're going to do calcium carbonate. So we're going to do calcium carbonate. And you will notice that the ending of carbonate is ATE. So that lets me know that I have a polyatomic ion and I am going to get that element symbol and oxidation number from off of the polyatomic ion sheet. So the first thing that I'm going to do is write the symbol for my for my metal, and my metal is calcium, and the symbol for my metal is Ca. And the oxidation number, I'm also paired with the oxidation number. And the oxidation number for calcium is +2. Okay. And then I'm going to look at my polyatomic ion sheet. I'm going to look for carbonate. I found carbonate right here. Okay. The symbol is next to it. Now, when I have a polyatomic ion, I put parentheses around my polyatomic ion. So the symbol for carbonate is CO3. And then the oxidation number for carbonate is -2. Now you notice that I put the oxidation number on the outside of the parentheses. And that is important because when I swap and drop, I am going to swap and drop my oxidation numbers as subscripts on the outside of the parentheses. I'm not putting anything inside the parentheses and I'm not taking anything out of the parentheses. This is a very important step because I don't want us to add anything inside the parentheses or take anything out of the parentheses. Those oxidation numbers are dropping down as subscripts on the outside of the parentheses. So I'm going to go ahead and write my arrows. And I hope that the arrows aren't confusing. I'm just using them as a tool for you to be able to visually see where that number should go. Okay. So once I swap and drop, my symbol should be, or my formula should be Ca2 parentheses CO3 and then the 2 on the outside of the parentheses. Now, when I had the slide up that gave us the steps, the very last step told us that we needed to simplify if necessary. Now, in the other examples that we did not need to simplify. But when I look at the subscripts that's on the outside of the parentheses, you want to see you're simplifying or choosing to simplify based off if those numbers on the outside of the parentheses can be simplified by a number 1 through infinity that will allow for it to be reduced to a lower number. So I know that 2, if I divide 2 into 2, it will simplify to be 1. So if I simplify this, essentially my symbol or my formula will be CaCO3 and I'm done. Because remember, once I simplify the 2's by dividing 2 into 2, it will simplify to 1 and I do not write 1 as a subscript. Okay? Now I know that was a lot. You can play this back as many times as you need to. And I'm also going to do another example. Okay. I also want to mention, well, let's just do another example. Hold on, let me see here. Which one can I do to show you another example? Uh, let's see here. Give me 1 second. Okay, let's just go ahead and do the next example. Okay, so the next example that we're going to do is magnesium nitrate. Let's do magnesium nitrate. Oops. 1 second. Let me fix this. Okay, so the next example that we're going to do is magnesium nitrate. Now remember, if I got ATE at the end, that means I have a polyatomic ion, okay? So I'm going to go ahead and write the symbol for magnesium, and the symbol for magnesium is Mg, and then the oxidation number for Mg is 2, positive 2, all right? So positive 2. And then because I have a polyatomic ion, I'm going to put a parentheses. And nitrate, the symbol is NO3. And I put my -1 charge on the outside of the parentheses. Then I'm going to do my process for swap and drop. And I'm adding my arrows to show where those numbers should go. Remember, you are not bringing down the charge. You are only bringing down the numbers. And your formula is going to be Mg parentheses NO3 2. And that is your answer for your magnesium nitrate. Okay. Now, I hope that was easy. I hope that was easy. If you have any questions, please comment down below so that I can further. Okay, so next, as promised, let's do the calcium fluoride. And I'm pretty sure that you got it correctly when you tried it. I'm sure you did. I just have faith in you. All right. So calcium fluoride. So first thing that you're going to do is write your element symbol, and then you're going to write your element oxidation number. And for calcium, it is +2. And then your symbol for fluoride or fluorine is F, and then your oxidation number is -1. When you swap and drop, okay, your formula is going to be CaF2. Now remember, I have the arrows pointing exactly where the number should go, and this is what you should have gotten for calcium fluoride. Now, I hope this video really helped you when it comes to writing ionic formulas. If there are any questions that you have, please make sure that you write it down in the comments below, and I'll be sure to address it in our next video. Now, in our next video, I am going to write how we, or do the steps in the tutorial of how we write the name of ionic compounds. So I hope this helps, and until the next video, see you later. Bye.
Don't play with it, don't be dishonest. Ay, still not understand.